in the reaction which intermediate is formed? See the question, this is very important, okay. This is acetaldehyde or ethanol. When acetaldehyde reacts with dilute sodium hydroxide, you get the product. Can you guess which is the product? Good. This is aldol condensation. You get aldol as a product. So remember it, any aldehyde or any ketone, if it has alpha hydrogen atoms, this is alpha hydrogen. What are alpha hydrogen? Remember it, this compound contains aldehyde functional group. The carbon adjacent to the functional group carbon, if contains hydrogen atoms, they are called alpha hydrogen. Similarly, any ketone, if it contains alpha hydrogen atom, when reacts with dilute alkali, you get a condensation product called aldol, and the reaction is called aldol condensation. So this reaction is an example of aldol condensation, okay. And remember it, aldol condensation occurs via intermediate formation of carb anion, and the carb anion which is formed, see the mechanism of the reaction. Remember it, in aldol condensation, whether you use aldehyde or ketone, always two molecules are used. What is the technique? Draw the first molecule as usual, and the second molecule split one alpha hydrogen atom, okay. This is the second molecule. The reaction occurs in basic medium. So this is here OH ion acts as base, and remember is base always abstracts a proton. Base always attracts a proton. So whenever the base attracts a proton, then this bonding electron comes on this carbon atom. So here water is eliminated and you get CH2 negative, C double bond OH. Any carbon carries negative charge called carb anion. So remember it, during aldol condensation, carb anion intermediate is formed. This carb anion is stabilized by enolization. That's another entrance question. This carb anion is stabilized by enolization. This is another part of entrance question. This type of question you never see in board exam, okay. So enolization is a type of tautomerism. Actually, this is a type of tautomerism. Later on, I will discuss tautomerism, okay, in another class. It comes here, it goes here. So CH2 double bond C negative H. This is ketoform. This is ketoform. And this is enol form. So this type of rearrangement is called keto-enol tautomerism. Once again, this type of rearrangement is called keto-enol tautomerism. And if any intermediate, whether it is carb cation or carbon ion or free radical is stabilized by resonance, remember it, that intermediate is formed generally. This is step 1, okay, step 1. Now I have already mentioned you that intermediate is not the product. So in step 2, another molecules, actually in this reaction always 2 molecules are used. I will write the reactions, okay. Now another molecule, this is the first molecule of acetaldehyde. Now the another molecule, draw the another molecule, because in this reaction always 2 molecules are used and they never mention that 2 molecules are used, they only write it, okay. So you have to remember it. So this plus this carbon ion. Now this reaction is a step of nucleophilic addition reaction. This is an example of nucleophilic addition reaction. How to remember? As oxygen is more electronegative than carbon, so oxygen attracts 1 pi bond. As soon as oxygen attracts 1 pi bond from carbon, it comes here. So you get the product here, CH3, C, double bond changes to single bond, hydrogen right here, CH2OH. Actually, when oxygen attracts the pi bond, this carbon becomes positive charge and this negative gets attached. This part is called nucleophilic addition reaction. So now you know that the reaction occurs in presence of aqueous medium, that is dilute. So water from the solvent comes here and it splits. So you get the product. This is called aldol. As this compound contains aldehyde group ALD and alcohol, so it is called aldol. So it is called aldol. So remember it, though I have told you that GOC, general organic chemistry, is going on, but actually I am mixing GOC with class 12 where it is required, okay. So remember it, this is the mixing process, okay. So now remember it. I have seen another question regarding with this. Aldol, if heated, what happens? This is the extra part of the question. If aldol is heated, what happens? See the question, okay, see the question. I think you understand it, aldol condensation. So once again, listen how to remember aldol condensation. Listen how to remember aldol condensation, okay. So aldol, continue, okay, aldol condensation. Remember it, aldehydes or ketones having alpha hydrogen atoms, when treated with dilute alkali, then condensation occurs. The reaction is called aldol condensation. During aldol condensation, whether it is aldehyde or ketone, 2 molecules are used. So the technique to write the aldol condensation, draw the usual structure of first molecule of aldehyde. I have taken here acetaldehyde plus, whenever you write the another molecule, just split one alpha hydrogen like this. Just write one alpha hydrogen, this is the alpha hydrogen separately. The reaction occurs in presence of sodium hydroxide or any alkali, maybe potassium hydroxide. What is the technique here? Just shift one pi bond, shift the hydrogen here, attached here. So you get the product CH3COH H CH2 C double bonded OH. This is aldol. Actually aldol is general name. It has some IPC name 1, 2, 3, 4. So it is 3 hydroxy methane, ethane, propane, butane, but 1L or butanol. Generally it is called aldol. So the question is that if it is heated, what happens when? I have seen this question in entrance. During this reaction, what the product which is formed on heating, what is the final product? They have given the option in final product. Aldol undergoes elimination of water, okay, here. Dehydration, loss of water is called dehydration. So OH and from here hydrogen and comes here. So the product you get CH3CH. This bond comes here, so double bond CH and this. This compound is called, this is a type of alpha beta unsaturated aldehyde. This is called alpha beta unsaturated aldehyde. This is a type of compound. How do you remember it? This is the functional group aldehyde. This is alpha position, this is beta position, as alpha and beta position contains unsaturation, that is double or triple bond called unsaturation. So usually this type of compounds are called alpha beta unsaturated aldehydes. It has some name, crotonaldehyde. So it has name crotonaldehyde, crotonaldehyde, okay. Unsaturated aldehyde, it is called crotonaldehyde. Now listen, another important question, okay. Listen the question, so remember it. I will discuss the most important questions along with its explanation. If you require any basic knowledge, please do write at my comment section, okay. Actually medical or engineering entrance needs 1 complete year, but I have only some days in my hand. So I will discuss and try to explain the proper explanation on the best questions which I have seen in previous years in different All India level exam, okay. So the another question is that this is the reaction question. See the question. This is another important questions, okay. This is another important questions. So they may ask, what is A here? Not this. A is say option A, CHRO crotonaldehyde, HYD, okay. Say the option B, PHORONE, phoron. Say the option C, acetyl oxide, and say the option D is chloritone. Can you tell me what is the answer here? This is not the question, this is the question. Question is on A, not on this. This is acetone. This is acetone. When reacts with dilute barium hydroxide, you get a product which on heating you get the final product, and the question is asked, what is the final product here? Anyone, can you guess? This is acetyl oxide, okay? So see the answer or explanation. See the explanation. So as you know that this is a type of aldol condensation, okay? This is a type of aldol condensation because you know that both aldehydes and ketones having alpha hydrogen atoms. So I have already told that during aldol condensation the technique is write the first compound as usual structure, and for second compound write one alpha hydrogen. Here also alpha, here consider any one alpha hydrogen atom separately. This is base catalyzed barium hydroxide. You may use sodium hydroxide or potassium hydroxide, but in case of acetone, barium hydroxide gives more product. So shift here, shift the hydrogen here and attach here. This is the technique. So the product is, during aldol, the product is like this way. CH2C so when it is heated, this product, when it is, this is called diacetone alcohol. This is called diacetone alcohol, okay? When it is heated, water is eliminated, and remember it, during elimination reaction in most of the cases from adjacent carbon two group or elements are eliminated. Actually this type of elimination is called alpha elimination, okay? Alpha beta elimination or 1-2 elimination. So water is eliminated here, from here OH, from here one hydrogen, and the bond shifts here to fulfill the tetravalency of carbon. So the final product you get CH3 double bond. This is CH3, okay? Actually double bond, one hydrogen is removed here, so CH, C double bonded O, CH3. So this is the final product, that is A is this, and it is called acetyl oxide. This is alpha beta unsaturated ketone. General name is alpha beta unsaturated ketone. Why it is called alpha beta unsaturated ketone? This is keto group. The first carbon is called alpha, the second carbon is called beta, so this is called alpha beta unsaturated, okay? So I think you understand it. This is aldol condensation of acetone. They never mention two molecules, okay? They never mention two molecules. Now the next, so remember it, reaction intermediate is going on, okay? Reaction intermediate is going on. So another question, this question carries an important role in organic chemistry. So this is the very important question. So the question is, in the reaction CH3NH2 plus CHCl3 plus alcoholic potassium hydroxide or sodium hydroxide, you get the product. The reaction occurs, the intermediates is option A CH3 positive, option B CCl3 positive, option C CCl3 negative, and option D CCl3 dot, and option D CCl2 double dot. So in the following, which intermediate is formed here? Okay, carb cation, this is also carb cation, this is free radical, and this is carbene. This is carbene, free radical, carb cation, and carb cation. You know that there are generally 6 types of reaction intermediates: carb cation, carbon having positive charge; carb anion, carbon having negative charge; free radical, this is a neutral species, carbon having single electron; carbene, this is the neutral species, carbon having 2 electrons; nitrene, this is also neutral intermediate, nitrogen has lone pair of electrons; and another is benzene, that's also reaction intermediate. Okay, so the answer is this is dichlorocarbene. So the reaction occurs via dichlorocarbene intermediate. One thing you remember it, in organic chemistry, this is the technique to remember. In organic chemistry, if any reaction occurs with chloroform and alkali, everywhere the intermediate is dichlorocarbene. Once again, during an organic reaction, if the reaction occurs with chloroform and any base or alkali, the intermediate is always dichlorocarbene. So see the reaction mechanism. This reaction itself is a very important. Okay, see the reaction mechanism. So step 1. In step 1, in the first step, these two react to form intermediate base from potassium hydroxide. Okay, from potassium hydroxide plus, this is chloroform. Write chloroform in this way. This is very important for entrance. Okay, as it's a base, and you know that base always attracts a proton, so the bond shifts here, and you get CCl3 negative plus water. Remember it, I have seen in JEEMAINS without mention, they have mentioned 2 intermediate. Here I have mentioned only 1 intermediate, but they have mentioned 2 intermediate. This is also intermediate. Okay, trichlorocarb anion, trichlorocarb anion. So remember it, this is also intermediate, trichlorocarbon anion. But as chlorine has very high electronegativity, it is very unstable, that's why it releases one chloride ion, and you get CCl2 dot dichlorocarbene. So this is the intermediate also. This is the main intermediate, dichlorocarbene. But if the option is given in both way, this and this, both are answer. Both are answer I have seen in JEEMAINS. Okay. Step 2. This dichlorocarbene gets attached here. The second step is not so important, okay, due to little time. Only remember it, this attracts here and you get the product, the final product. So remember it, the complete reaction is this is CH3NH2, this is very important, plus CHCl3 plus alcoholic potassium hydroxide, and remember it, this amino group will change into isocyanide group. Okay, potassium combines with chlorine to form KCl plus water. Remember the complete reaction 3 3 3. So it is methylamine. It is 1 degree amine, primary amine. If any amino group contains NH2 primary, NH secondary, N tertiary, and this is isocyanide, methyl isocyanide. It has very unpleasant smell. Okay, it has very unpleasant smell. So IUPAC name also remember it. The IUPAC name of this compound is methane carbylamine. NC is called carbylamine. So it is methane carbylamine. The reaction is called, can you tell me what is the name of the reaction? The reaction is called carbylamine reaction or isocyanide test. So remember it, the carbylamine reaction is the reaction of primary amine. It is an identification test of any primary amine, aliphatic or aromatic, to form isocyanide which has unpleasant smell. Okay, to form isocyanide which has unpleasant smell. So I think you understand it. Any primary amine, aliphatic or aromatic also, this is aniline, this is aniline. Aniline also undergoes the same reaction to form phenyl isocyanide when treated with chloroform and alcoholic potassium hydroxide, that is both methylamine or any primary amine. This is aliphatic primary amine or aromatic primary amine, undergoes carbylamine reaction. Okay, how to remember? The amino group directly will change, and remember it, carbylamine reaction or isocyanate test occurs via intermediate of dichlorocarbene. Actually, I have seen in JEEMAINS both have options given, so both correct if options are given in both. So the next question, that's also very important question. Okay, see, reaction intermediate is going on. From today onwards, I will upload each and every day one video, but that is not too long video. Okay, so the question next question, in this reaction CH3C double bonded O NH2 plus Br2 plus dilute KOH CH3NH2, the intermediate is a carbene benzene nitrene carb anion. Can you tell me, at first tell me what is the name of the reaction, okay? At first tell me what is the name of the reaction. This is very important. Yes, this is Hofmann bromamide degradation reaction. This is an example of, see the explanation, this is an example of Hofmann bromamide degradation reaction. This is an example of Hofmann bromamide degradation reaction. And during Hofmann bromamide degradation reaction, the intermediate is nitrene intermediate formed, okay? The reaction occurs via formation of nitrene intermediate. Actually nitrines are neutral species, R C O N, this is nitrene. Actually nitrines are neutral species having lone pair of electron on nitrogen. This is actually intermediate. Remember it, Hofmann bromamide reaction is an example of molecular rearrangement reaction. This is also entrance part, okay? This is an example of molecular rearrangement. That's also important. This is an example of molecular rearrangement. So understand the mechanism of Hofmann bromamide degradation reaction. Before that, remember the complete reaction. That's also very important, okay? So see the complete reaction and then I will discuss how nitrene is formed as intermediate. So remember it, very important question is going on for your forthcoming entrance. I will hit that questions which may come in your entrance exam, okay? Not the foundation course, because time is very short. So listen the complete reaction, the complete explanation, okay, going on. The complete reaction is, so before that, remember it, Hofmann bromamide reaction occurs only by primary amide. Remember it, only primary, this is another thing, just remember, only primary amide undergoes Hofmann bromamide reaction. What is primary amide? RCONH2, this is primary amide. If you replace one hydrogen by any alkyl group, if you replace one hydrogen by any alkyl or aryl group, if you replace one hydrogen by any alkyl, this is called secondary amide. If you replace both the hydrogen atoms by alkyl or aryl group, this is called tertiary amide. And Hofmann bromamide degradation reaction is the reaction of only primary amide, secondary amide and tertiary amide, they do not go Hofmann bromamide degradation reaction. This is also I have seen in entrance, okay? Which of the following amide undergoes Hofmann bromamide reaction? So see the reaction here, this CH3, remember it, benzamide, if instead of here benzene ring is there, that also undergoes Hofmann bromamide reaction, okay? So dilute potassium hydroxide. So the product is, just follow the technique. This is I erase it, okay? Just remove it. This is acetamide. So you get the product CH3NH2 methylamine plus potassium combines with this to form potassium carbonate. Remember the complete reaction, this is another important. Potassium combines with bromine to form potassium bromide and water is there. So the balance 2, 2 and 4. Similarly, remember it, benzamide also undergoes the same reaction, okay? Benzamide also undergoes the same reaction, CONH2. This is benzamide when reacts with bromine, and instead of potassium hydroxide you can use sodium hydroxide also. So just remove the CO bond. So you get aniline here, primary amine. So remember it, during Hofmann bromamide reaction, amide will change into primary amine. So during Hofmann bromamide reaction, amide, 1 degree amide will change into 1 degree amine. That is, amide will change into amine. Remember, this is also entrance question, okay? Actually, if any topic is very important for entrance, each and every corner is also important. So you get the product here, aniline plus sodium carbonate plus sodium chloride plus water, 4, 2, 2. Now see how nitrogen is formed as intermediate here. See how nitrogen is formed as intermediate. This is the main reaction, and I have mentioned which of the intermediate is formed here. Remember it, during Hofmann bromamide degradation reaction, the reaction follows the intermediate formation of nitrene. So see the mechanism of the reaction. Actually, not all part of mechanism is necessary, okay? Every part is not necessary. In the first step, listen, in the first step, this amide, this is acetamide, step 1, acetamide reacts with bromine and potassium hydroxide. 1 hydrogen is removed by bromine, so CH3CONHBr. The product is N-bromoacetamide. In the second step, this N-bromoacetamide reacts in this way. As the reaction occurs in base catalyzed base, so you know that base always abstract a proton. As the reaction occurs in base catalyzed, so remember it, the base always abstract a proton. So the nitrogen, as it is more electronegative than hydrogen, so it gets the electron, extra electron, okay, it gets the extra electron. So it becomes negative charge. By gaining the electron from hydrogen, the nitrogen becomes negative charge. Now, bromine, as it is electronegative, nitrogen also highly electronegative, and 2 electronegative cannot exist, and that's why this bromine releases as bromide ion. This bromine releases as bromide ion, and so you get here CH3C double bonded ON. Nitrogen as releases its own electron to bromine, so it becomes like this. This is called nitrene, and it is believed that during, this is the intermediate actually, during Hofmann bromamide reaction, the reaction follows via intermediate formation of nitrene. Bromine releases but takes the electron from nitrogen. That's why the nitrogen loses its negative charge, changes to neutral. So remember it, this negative actually negative of this. Now it is believed that this nitrene undergoes rearrangement. Okay, it is believed that this nitrene undergoes rearrangement to form isocyanate. That's a very important point, so see it. Now I will erase it. Okay, continuation mechanism is continued. Another part of this, okay, this nitrene undergoes rearrangement. The nitrene undergoes rearrangement. That's why it is called molecular rearrangement. That's why Hofmann bromamide reaction is an example of molecular rearrangement to form that. This part is also entrance question. Okay, this part is called isocyanate. To form isocyanate, see how isocyanate is formed. The lone pair comes here and the whole methyl group shifts here. So you get the product here, O double bond C double bond N CH3 double O double bond C. The lone pair comes here, so it becomes double bond, and here it is CH3. This is called methyl isocyanate. This is called methyl isocyanate. So remember it, this part is an example of molecular rearrangement. So Hofmann bromamide degradation reaction is an example of molecular rearrangement, okay, followed by intermediate formation of nitrene. Now this compound reacts with water. This compound reacts with water like this way. Break it. So you get the final product CH3NH2 plus carbon dioxide, methylamine. That's, you get it. See. So I think you understand it, remember it. Due to shortage of time, I will discuss the most probable questions which may come in your entrance with a proper explanation, but not all the syllabus details, okay? So please subscribe my channel, this is my request, and you get more and more uploaded video, and every video has some important questions. Lots of important questions are there with explanation. So thank you being with me.